Okay, everyone, what we're going to do is just show a few more examples for solving rational equations. This is going to match your day 7 notes that we've already have posted. Again, we're solving rational equations. Now, this is done a little bit differently than how we add and subtract rational equations. Remember, there's two versions. I'm going to focus on the version that tries to immediately get rid of your denominators. So the first thing I want to do over here as a first step is look at my denominators, both of them, and realize that was just a 1, so it doesn't matter. That I can never get an answer of x equals 3. If I do, I'm going to have to say stop, that's an exclusion, and then we'll go from there. My LCD is also important because that's what's going to solve the whole denominator issue and try to cancel, or excuse me, divide out those. So I can look at all the denominators and realize this is a pretty simple LCD. It's an x minus 3. So now I'm going to take that LCD and multiply by every single piece of the 3-parted equation I see. So I'm going to use the LCD here and multiply on the left. I'm going to use the LCD, let me squeeze it in on the second part, which is on the right. I'm going to also use it on the second part, far with the 9. So there's 1, 2, 3 fractions that I have to multiply by LCD. By doing that, if I lock and load these quantities, I can quickly realize that right off the bat, if I want to put these two together, I'm going to reduce those and get just the x as a remainder. I can look at the second piece also and realize those reduce, and that just leaves the 3. The last one does not have a denominator that reduces, so I have to finish out what I started there. Immediately you can see, oh, this is so much prettier, simpler, I should say, than the original fraction problem that was rational everywhere. Now I have no denominators, and now I am back in Algebra 1, and I am literally just solving like I did back in my beginning days, which is super simple. So we just isolate all the variables as we normally would. And now we get x is equal to 3. So we're not going to circle it because we don't know if that's really the answer. We have to check for exclusions. So you're going to go up here and say, oh, warning, 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 warning. I got 3, but I can't have 3. It won't make the original problem doable. It won't work. You can't divide by 0, which means there's no math here that works for this. So since that was an exclusion, I'm going to literally take my pen and cross it off, and I'm going to say to myself, this is an extraneous solution, meaning it doesn't work, it's extra. So in all essence, for this problem, there is no solution. So let's try another example. All right, so this problem looks a little long as well. I also don't like the fact that there's no denominator there, so I'm going to put one there. And I'm going to start off the same way. I'm going to find my exclusions, and I'm going to find my LCD like in the olden days. I need to factor the right side denominator, just so, so it's easier to see what both the exclusions are and the LCD. So I can see from right here on the right that x cannot be equal to 0, and then x plus 4 cannot be equal to 0, which means x cannot be negative 4. So there's an exclusion, meaning a no-no. There's an exclusion, meaning you can't use it. So we're going to look out for those and be, like I said, always fair warning. If one of those shows up when I get done, I have to cross it off. The LCD is exactly what I just tried, one of each. So I need to use that in all cases. So let me rewrite this problem again, move this to the side. I need to multiply every single 1, 2, 3 pieces by that, both parts, okay? So let me squeeze it here. I'm going to multiply it there, I'm going to multiply it there, I'm going to multiply it there. This worries me, this minus sign, so I'm just going to throw it up on top so I don't forget it. All right, here comes the multiplication. One of each, and again, that's all over 1. Here, it's one of each, all over 1. don't want to lose that equal sign, so let me make it a little darker right now. And then over here, 1 of each, all over 1. So I now have to work out that fraction, work out that fraction, work out this fraction. Let me get this a little better. And when I say work them out, I mean do the multiplication that I see. Do this, reduce if I can. Do this, reduce if I can. Do this, reduce if I can. So nothing reduces in the first one, so you're going to have to do that multiplication. So we really have 2x times x plus 4. I'll come back and finish that later. There's your plus sign. This one has a negative 3. It has an x, but if you notice, these canceled out, divided out. Bring that equal sign back down. Now, you've got this here, but remember, it really means this. And don't you recognize that's the same? So this and this reduce entirely and just leave your 12. That is so much nicer. We can now finish it back like in Algebra 1. And again, now we're out of the complicated pre-calc zone and back into Algebra 1 simple steps. So the key step is that multiplication, 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 reduce, reduce, reduce where needed. Your goal, remember, for these is to rid yourself of the denominator as quickly as you possibly can. So we've got 2x squared plus 5x, move the 12 over, minus 12 equals 0. We're going to have to factor that. So we have 2 possible answers. First times first. For 12, I'm either going to have to use a 6 or a 2. With a 4 or a 3, or one or the other. So 6 is going to give me 12 here, and 2, that's not going to work. So it looks like we're going to have to use the 4 and the 3. So 4 here gives me 8, and that's going to be the 3 there, 8 and 5, or 8 and 3, that gives me 5. So I know I'm good to go there. So let's just finish this up here. Zero product property. Zero product property. Ooh, 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 ooh. Fair warning, fair warning, fair warning. That's going to be a problem. Why do I know that? Look up here. Okay, we'll get to that in a second. Move here 3, move here 2. X is 3/2. That is not an exclusion, so I love it. But my warning was if I solve this one, I'm going to get negative 4, and that was a oh no zone. We can't have 4. It doesn't. Or negative 4, it doesn't work because if I put it there, that'll be undefined and then my math falls apart. So negative 4 is not going to work. So I'm just going to go like this. I'm not going to erase it. I want you to know communication-wise that I understand its algebra is working, but its original solution doesn't work. So I'm just going to say extraneous, no go. Don't use. And there you go. So there's 2 good examples. I believe we did the others in class. Let me do this one just in case, and then I'll shut this video down and you can rewatch it as many times as you need and then reach out. Okay, x cannot be negative 5, x cannot be positive 5. The LCD is 1 of each. I'm going to be in a good place here. I need more room. So let's write that multiplication now. So now we got to multiply by each of the parts by both factors. Over 1, both factors. Sorry, I'm running out of room on that second part. Over 1. Let's make that equal sign darker. Both factors over 1. Okay. Now your goal is to reduce. So is there an x plus 5? Sure. Is there an x minus 5? Sure. Is there both of them? Yes. Now I can write down what the leftovers are. So I've got a 4 and an x minus 5. I have a 2 and an x plus 5 left over after division. And here I only have the 32. So let's just keep working. 4x minus 20 plus 2x plus 10 equals 32. Now again, we're back in Algebra 1, so this shouldn't be hard to do. 6x minus 10 equals 32. 6x equals 42. X equals 7. Just before you get excited and say, I'm done, you double check your extraneous. Nothing's in the way. You are out. And you know that 7, if you put it in the left side and the right side of this problem, those two problems will turn out identically. There you go. Hope that helps. Reach out if you have any questions. Thanks for listening.